We all know the Hollywood version of how the world changes, a man pacing a dark laboratory in total isolation until a magical insight appears out of thin air to change his life. But the device that makes this video and the entire digital world possible followed a different path. The transistor was born in a corporate lab through years of frustrating and deeply human teamwork. Clinging to the image of the solitary inventor hides the reality of scientific progress. Most breakthroughs demand the friction of multiple minds working on the same stubborn problem. To see what that looked like in practice, look at this. This is the first generation of computing in the 1940s. Processing basic data required thousands of pounds of equipment, filling entire rooms with towering metal cabinets. Those cabinets relied on these vacuum tubes. They amplified electrical signals, but they were fragile glass bulbs. They consumed massive amounts of electricity, generated blistering heat, and constantly burned out. For Bell Labs, this was a physical limit they had to break. To scale up global telecommunications, they needed an amplifier made of solid material, something that removed the need for fragile glass. The leader of the project, William Shockley, designed a theoretical silicon amplifier on paper, but when his team actually built it in the lab, it didn't work. Shockley brought in two researchers to find the flaw: John Bardeen, a quiet theoretical physicist, and Walter Brattain, an experimentalist who specialized in building the hardware. Overcoming the limits of early electronics required this specific mix of thinkers. They spent 2 years methodically troubleshooting Shockley's failed theory together. Bardeen spent months on the math before identifying the culprit. He realized electrons were getting trapped on the outer layer of the semiconductor, forming a barrier that blocked the current. This diagram shows how they bypassed that barrier. By manipulating a semiconductor crystal, they could create a path for electrons to move through the interior of the material. This is how the amplification works. This tiny input current at the base acts as a gate, controlling a much larger flow of current from the emitter to the collector. In late 1947, Brattain put Bardeen's theory into physical form. Using a plastic wedge, gold foil, and a sliver of germanium, he built a makeshift apparatus that successfully boosted the voltage of an incoming signal. This was the intersection of Bardeen's deep physics and Brattain's engineering. Their combined work created the first solid-state alternative to the vacuum tube. William Shockley was not in the room for the successful test. He viewed the team's success without him as a direct threat to his reputation as the group's leader. Shockley isolated himself in a hotel room for weeks to design a superior version, the junction transistor, entirely on his own, hoping to reclaim the spotlight. When telling the public, Shockley framed the story around himself. In staged photographs like this one, he obscured their collaborative work. Look at the composition. Shockley sits at the center, pushing Bardeen and Brattain to the background, fixing the lone visionary myth. The device, built on quiet collaboration, was immediately co-opted by a single ego. It was a precedent that would shape the culture of the tech industry for decades. Bell Labs began licensing the technology across the industry, sharing the cookbook for manufacturing transistors with any company willing to pay. This resulted in the first commercial leap, the Regency TR-1 pocket radio. For the first time, complex electronics could fit in a single hand. These individual transistors were soon miniaturized and packed together into integrated circuits like this one. It was the necessary step to create the microchips we use today. Shrinking that physical switch allowed engineers to build the infrastructure of our modern world, from the earliest mainframes to the smartphone in your pocket. Shockley eventually moved to California to help spark Silicon Valley, but his career ended in alienation and the pursuit of controversial theories on race and intelligence. John Bardeen took a different path. He left Bell Labs for academia and spent years stubbornly holding on to a problem that had defeated Einstein: superconductivity. To solve it, he built a small, tight-knit team, mentoring a postdoctoral fellow and a graduate student to help him visualize how billions of electrons could interact in unison. When that team finally succeeded, Bardeen returned to Stockholm. He is the only person to ever win 2 Nobel Prizes in physics. The foundation of our digital world was built in the silence of people working together. It is a legacy that belongs to a man who preferred the strength of the team to the glamour of the spotlight.